Example 7.3 Head-on collision. Consider a head-on collision of a full-size SUV of mass m equals 3023 kg and a compact car with a mass small m equals 1184 kg. Each vehicle has an initial speed v equals 22.35 meter per second and they are moving in opposite direction. So as shown in the figure, we can say Vx is the initial velocity of the compact car and negative Vx is the initial velocity of the SUV. The two cars crash into each other and become entangled, a case of totally inelastic collision. What are the changes of the two cars' velocity in the collision? Neglect friction between the tires and the road. So here in this question, you have a compact car of mass small m equals 1184 kilogram and it is moving with an initial speed of 22.35 meter per second. And then it collides with an SUV that has a mass capital M of 3023 kilogram. And it is moving with the same speed but in opposite direction. So we write the speed as negative 22.35 meter per second. We will write Vc for velocity of the car and Vs for velocity of the SUV. We need to find what is the change in velocity of the two cars after collision. The change in velocity is delta V, which is nothing but V final minus V initial. In order to find this change, we need to find what is the final velocity of the two cars. Now, this is an example of totally inelastic collision. In totally inelastic collision, the two colliding objects after collision lock together or they stick to each other and move with a common speed v. So this is the common final speed we need to find in order to find the change in velocities. Now let's use the law of conservation of momentum to find this velocity. We know from the law of conservation of momentum, momentum before collision must be equal to momentum after collision. Momentum before collision is the sum of the momentum of compact car and SUV. So we write this as mass of the car into velocity of the car plus mass of SUV into velocity of SUV equals after collision they stick to each other and move with a common speed v. So we write their masses as combined mass of car plus mass of SUV into their common velocity. We want to find this v, so let's divide with the mass. We get v equals mass of car, velocity of car, plus mass of SUV, velocity of SUV, over mc plus ms. Now let's substitute. Mass of car is small m, which is 1184. Velocity of car is 22.35, plus mass of SUV is 3023. Velocity of SUV is the same value but negative, over mass of car 1184 plus mass of SUV. And when you solve this, you get the final speed of both cars to be equal to negative 9.77 meter per second. The negative sign makes sense because the SUV has greater momentum and after collision they will continue to move in the direction of SUV. Now let's find the change in their velocity. We will first begin with the car. Delta V for car will be its final velocity minus initial velocity. Final is negative 9.77, initial is 22.35. So delta V for car is negative 32.12 meter per second. Then we do the same thing for SUV. Delta V for SUV will be V final minus V initial. V final is the same, negative 9.77 minus V initial is negative 22.35. So we get delta V for SUV to be equal to 12.58 meter per second. So these are the changes in the velocities of the two cars after collision.